Someone noticed that I hadn't done this practice test for solution at the practice test for probability distributions, including binomial distributions. So we'll, excuse me, we'll go ahead and do this one. Provide an appropriate response. The random variable x represents the number of cars per household in a town of 1,000 households. Find the probability of randomly selecting a household that has less than 2 cars. So the key words here, some of the keywords, less than 2 cars means x has to be less than 2. That means it needs to be either 0 or 1. Okay, can't be 2, just 0 or 1. So we're going to look at these two, and we're going to calculate. And really think of it, it's really 0 or 1. This is an OR probability. And so we will add those two probabilities together. The way we go about doing a discrete probability distribution is we would get the relative frequency, right? So we take each of these numbers, divide by the total, which is 1,000. You could keep going, but since we only need 1 or 0 or 1, we could just calculate these two. It's nice that we have 1,000. You move the decimal place over 3 places, so the probability of x happening for 0 will be 0.125, and the probability of having 1 car, move it over 3 places, will be 0.428. And we just need to add these two probabilities together. So we get 13 carry the 1, that's going to be a 5, and that's going to be a 5, so 0.553. That answer's right there. All right. For question number 2, insurance actuary asks a sample of senior citizens the cause of their automobile accident over a 2-year period. The random variable x represents the number of accidents caused by their failure to yield the right-of-way. Use a frequency distribution to construct a probability distribution. So 0, 1, 2, 3, 4, 5. So we can have x equal to each of these. And the probability of x for each one of these, you have to take the total divided. So we're going to get a relative frequency. So we'll add these together. Just to be safe, we'll go ahead and use the calculator. Oops. You have to add 4 plus 3 plus 12 plus 3 plus 2 plus 1. We've got 25 total. We're going to take each of these and divide by 25. And we could use these fractions, or at least the reduced fractions would be nice, but we could also go ahead and take 4 divided by 25. That's 0.16. 3 divided by 25. 0.12. 12 divided by 25. That's 1/2 or 0.5. Again, you could go ahead and do that. Oops, not that. Oh, it's not quite. That would be if it was 24. See, I'm glad I plugged it in. I was almost going to just do 0.5. That would have been a little bit off. 0.48. Time you do math too much in one day and can't think anymore. 3 out of 25 is the same as 3 out of 25, so this one's going to be 0.12. 2 out of 25, 0.08, 0.08, and then 1 out of 25 should be 0.08. 0.04, right? That's half of 2, and that's exactly what it is, 0.04. And that's what we needed. We constructed the probability distribution right there. Okay. Determine the probability distribution missing value, the probability of tutor will see 0, 1, 2, 3, 4. So the main thing to remember with the probability distribution is the total has to add to 1, 100%, right? 1. So what we do is we add all these together. Come up with 0.36, and we're going to take 1 minus that. Notice there's the answer key here, so I can just pull back that answer, and we get 0.64. That's what we got there, 0.64. Random variable x represents the number of tests that a patient entering hospital will have, along with the corresponding probabilities. Find the mean and standard deviation. Okay, so these are probabilities, not decimals, but that's okay. We can use the statistics function here. Go back here. We can actually set up a distribution by going here. So we'll put the values here. The random variable goes in the V1. The frequency is the fractional part. That'll go in the next one. And then we can just calculate this. So I'll just go 0, 1, 2, 3, and 4. So those are random variables. And we can just enter 3 divided by 17, 5 divided by 17, 6 divided by 17, 2 divided by 17, and 1 divided by 17. We've got all our probabilities in here. Now if we arrow up, we can go over to the statistics or the stats part. We'll hit enter, and it calculates everything for us. We are going to get, now the thing is there's 2 standard deviations, right? Sample standard deviation. But notice, because these are fractions of 1, we've got an infinity there. So really there's only 1 standard deviation that's usable. That's this one here. So standard mean and standard deviation. I'll just do this standard deviation first. 1.087. They don't tell us how many. Oh, I guess we just look down here. 1. Oh, if you round that up, you get the 9. So it's got to be this one, right? We already know it. But the mean we're going to see over here is right up here, 1.58. So 1.59 rounded. So it's got to be B. Very good. For 5, find the mean of a binomial distribution for which n equals 10 and p equals 0.2. You have to remember is that for a binomial, there is a formula that the mean is equal to just n times p. In this case, n is 10, p is 0.2. So we just multiply those. Multiply by 10, it moves the decimal back 1. So this is going to be 2. It's right there. Again, an important formula to have in your notes that you get to use while you're taking the exam. All right. Find the standard deviation of the binomial distribution for which n equals 500 and p equals 0.89. Now the standard deviation also has a formula. Again, I'll just emphasize that the mean is n times p, but this one they just want the standard deviation. That is the square root of n times p times q. What is q? Remember, q is the probability of a failure, so you can always get q by taking 1 minus p. So in this case, q is going to be equal to 1 minus 0.89. So Q is going to be 0.11. Okay. So to calculate it, square root 500 times 0.89 times 0.11. And all we have to do is enter that into the calculator, into the calculation part. Square root 500 times 0.89 times 0.11. And we come up with 6.996, which would round to 7. There it is. Because they're only using 2 decimal places, and that's what we would get. All right. Question 7 here. According to police sources, a car with a certain protection system will be recovered 85% of the time. If 300 stolen cars are randomly selected, what is the mean and standard deviation of the number of cars recovered after being stolen? Mean and standard deviation. This time we want them both. Again, we use these same formulas that we had up here. This is a binomial distribution because you either recover a car or you don't. So right, true or false, success or failure. 300 is our in, and we can get our mean and our standard deviation. So the mean is going to be 300 times 0.85. That's 255. So it's either C or it's B. Standard deviation is going to be the square root of 300 times 0.85 times the complement of 0.85, or the complement to 1 is going to be 0.15, right? Probability of a failure, so 85% success, 15% failure. We multiply that out. Am I going to guess? Are we going to get that or that? I'm not going to guess. My mind is a little fuzzy right now. 0.85 times 0.11. What did I do? Oh, not 11. Yeah, see, I told you my brain's going. So I'm going to come up here. I'm going to go, okay, bring it back. It's 0.15, not 11. There we go, 6.18. It's actually leaning towards the other one, but that's why I backed off. Okay. Assume that male and female births are equally likely, and that the birth of any child does not affect the probability of the gender of any other child. So that means they're independent. Find the probability of at most 3 boys in 10 births. So you have to recognize this as being a binomial, so either success or failure, not really that one's more than the other, but so we're looking at male births. We could have easily looked at female births as being the success, but equally likely means 50% chance, right, which is a 0.5. So our P is 0.5. Since we are looking over 10 births, that's got to be what our N equals. And then we want at most 3, So that includes 3, but nothing more than 3. So that's 0, 1, 2, or 3. That's the key part. There is a binomial distribution in our calculator. So we'll go down to distributions. We'll go to binomial, and we have to put in the n, which is in this case 10, and the probability of a success, which is 0.5. Now we want the probability. You could come here, so you've got 4 different choices. This last one down here is equal to an item. So you could find equal to 0, 1, 2, and 3. So that's 4 different calculations you would do and then add them all together. That would work. However, we can also use the less than tool and go there. We want 3. We want x less than or equal to 3. And when we do that, we find that's 0.1718. 0.1718, which round for 3 decimal places would be this one here. 8 rounds up to 1 to 2. And there it is. Okay. Now be careful with the binomial distribution. Had they asked for find the probability less than 3, we would have actually had to put in a 2 here, because notice this is equal, less than or equal to 3, so it's going to include 3. If it had been less than 3, we would have had to put in 2, so we only get 2, 1, and 0. And you'll see that in, I think, one of the following questions. In fact, this last one. An airline has a policy of booking as many as 150 persons on a plane that seats only 140. Nice, right? But why do they do that? Because the studies indicate that only 85% of booked passengers ever show up. Find the probability that if the airline does book the 150 people for a 140 seat plane, not enough seats will be available. Okay, so what's in terms of binomial, right? Because a passenger will either show up or not show up. So the probability of a passenger showing up is 0.85. And in this case, the n, the number of trials, is the number of people that are booked. That's going to be 150. What we're going to want to use is the binomial distribution to see a probability. Not enough seats means how many people showed up. Well, at least 141 showed up, or maybe 142 or higher, right? So more than 140. So x has to be greater than 140, or x has to be greater than or equal to 141. So on a binomial, you'll see, well, we'll just leave it at that, right? So these are equivalent for this distribution. So we put in, go back to the start, and we put in our 150 for n, put in 0.85 for our probability of success, and we want this one greater than, we're going to do greater than 141, not 140, because 140 would be included. 140 people show up, there's enough room for everybody. 141 show up, there's not enough room. Now, I don't know if it makes that much different or not, but that's what we want to have. So what we get is this number 5.391, if we want to round that, times 10. This is what this e to the negative 4, that means an exponent of negative 4. That's scientific notation. What you do with scientific notation, since it's a negative exponent, that means a power of 10, you're going to move it back, sort of like dividing by 10. 1, 2, 3, 4. There's where the decimal is. We'll fill in zeros for these places. So our probability that we would list to 4 decimal places will be 0.0005. That's in the 10,000ths place. As a fraction, that's 5 out of 10,000 flights would actually end up being overbooked. They have to bump a person or 2 or 3 or possibly 10. If everybody showed up, that could occasionally happen. But again, it's very, very rare. And so business folks, they're going to book more people so that there's a better chance that they can actually have 140. And you can play with this, right? So you could come here, see how much, what was the probability of getting an exactly full flight. That would be exactly 140 people showing up. That's also very small, that's exactly 140. But if we change this to less than or equal to 140, right? Probability that nobody gets bumped is, almost 100%. There's that 5% little 5 in 1,000. So it's a very high probability that, yeah, we'll always, be able to fly. Now, we don't always get a full plane, but looks like you can see at 120 is kind of a cutoff here, and it gets really, really down there. So, one thing you might say, oh, I don't know, test is over, so maybe you're done. But I just like to play with these a little bit. Let's go 120 to 140. So that's a full plane, pretty full. 96% of the time you could fly with that by booking the 150. But you can say, well, what if they only booked 140? Let's see how that changes things. So 96% of the time you got 120, you're only less than 20 seats shy. But watch, if they were to only book 140 seats and have this sort of thing going on, watch what happens. Me, I'm watching too. I don't know. So let's put 120 to 140. Watch it. Last time it was 96%. It's only 46% chance that you're going to have, so there's a lot more chances you're going to have less than 120 there. See, actually half of this. So that's why they book the 150. Usually they're just fine, but if they only book 140 and people are only showing up 85% of the time, they're flying with a pretty light plane almost 50% of the time. That's why they got to do it. It's a business imperative to make money. Um, anyway, thanks for hanging out. This is the last video. Good luck with the test, and talk to you later.